Good morning and good evening, friends. Welcome to goonlinetrainings.com. So today is the second session, and today we're going to discuss about how to create a free Azure Databricks subscription. And creating a subscription is very easy, and you should not be worried about it. And you are going to be, understanding today how to create lifetime Azure Databricks subscription. It is a lifetime free given by community edition of Databricks company. And after that, we are going to be discussing about how to create a workspace. Workspace means a project, right? So in simple terminology, you're going to be creating a project or a folder or a workspace. After that, we'll understand Databricks UI components, how to create a workspace, how to create a cluster, and how to create a notebook, and how to run the jobs and everything. So, what are the libraries it is going to be giving you, and how to supply the data to the Databricks so that it can work on it. Experiment means for AI work. So, these are the agenda points I'm going to be discussing. And before that, I want to go give you Azure Data Engineering roadmap once again. So first month and second month, you're going to be working with the SQL and ADF, right? So SQL through videos we're going to be giving. Make sure you need to watch daily one video, and I'm going to be giving you target only 20 videos per month. Clear? So don't go more than that. 20 videos, the goal per month, first and second month. And daily, you must attend one live class. So 2 months, first 2 months, you are going to be completing this one, and daily 1 hour of class. Monday to Friday we'll have classes. Approximately 20 classes you're going to be attending. Every video you must watch and write the notes. Okay. And the third month onwards, we're going to be starting with ADB Azure Databricks Live and the Python. You are going to be learning through videos. Parallelly, these two things happen daily. Morning or evening you attend one live class, and the morning or evening you need to watch one video. That is first 2 months. Third month and fourth month, daily you need to attend one ADB live class, and Python you need to watch either from my channel or from the YouTube. That is also fine, because Python I'm not going to teach. It will be from the one more trainer. So if you like the content, just go practice it, or if you don't like this content, at least watch it from the go YouTube itself. So 30 hours basics you need to know, and clear. So that is what is important. Fifth and 6 months data warehousing, video synapses, projects, and everything we're going to be planning. Okay, so I wanted to give you the complete roadmap. Databricks is daily 1 hour. Again, it will be monthly. You can target 20 videos. Don't go more than that. Okay, so that you will get ADB also live classes, maximum 20 classes per month. Right, Saturday, Sunday, you write the notes and revise it. Revision is important. Fifth and 6 months data warehousing videos I'm going to be providing 10 hours. And in that Amazon project is there. Amazon project I have implemented with SSIS as a ETL tool. What you do, you need to implement the Amazon project with the ADF as an ETL tool. People already completed this, right? And the synopsis videos we are going to be providing. So this is by one more trainer, but beautifully as explained my older trainers. You can just watch those videos. Synapses is for the data warehousing purpose. Synapses is a data warehousing and data analytics course. It is, you must watch data warehousing, then watch Azure Synapses, and projects I'm going to be giving from the online. So these projects you're going to be working on from the fifth and 6 months, not my projects, but you beautiful YouTube projects. These are, I'm going to be giving you the URLs. You need to work on this, and then sample CVs and interview preparation questions I'm going to be giving. So, and if you're ready with your CV, I will review the CV. Then we can have 1 or 2 sample, mock interviews. You can attend one to one. It is not a group one. If you're ready with the content, I'm going to be taking some mock interviews. Even my friends who are working in Microsoft, right? So I was in Microsoft couple of years, so those people also interested to take your mock interviews. They are currently working in Microsoft. Some of them are in Redmond in USA, some of them in Hyderabad itself. So if you wanted to attend interview sessions with them, so we can also plan. And I'm going to be recording those interview sessions as well. So it will be one-to-one mock interviews. You have to register with me. You have my number, right? So you need to register with me for the mock interviews. Once the sample CVs, everything is ready, so that you will come to know where you're good and where you're bad. So by attending the mock interviews, this is the complete 6 months plan, right? So don't go for more than this. This is more than sufficient for you to, get the job. So most of the time, SQL questions are heavily asked, right? Not even Python also. Sometimes they'll ask you to give the problem, ask you to write the code in Python, right? String manipulations and all of them are important. Arrays, strings, lists, all these are important as part of Python. Just practice all of them. Every month you need to watch 20 videos so that 1.5 month you can compare this. So this will be 2 months course it is. And fifth month and 6 months you're going to be doing. This is the complete roadmap. And always take a screenshot of this, stick it to your wall and try to practice like that only. If you have any doubts anytime, you can just come back to me, guys. Chal. Now, today I'm going to be showing you, create how to create a free subscription. Before that, I wanted to recap whatever we have discussed yesterday, right? So, what is the big data we have discussed? What is data warehousing? Also, we have discussed. What is a cluster? And a data warehousing versus big data. And to store big data software today, we have thousands of tools, but open source free tools, free softwares are Hadoop and the Spark. And if you wanted to understand Spark architecture, you need to understand Hadoop architecture also. Right? Couple of days, we are completely focusing on these architectures. Then slowly we are going to be practicing, we're going to be starting practicals. Okay. So, okay. Now, as we know, if you wanted to store big data means, as somebody said, three V's, right? Petabyte, zettabyte, yottabyte of data. Apache Hadoop and Apache Spark and other 1,000 tools are available today to store your data. So AI is going to be working most of the time on unstructured data, not on the structured data. I have discussed this point as well, right? So variety of data, string, semi-structured, structured, semi-structured, unstructured data, maybe social media, web browsing data, weather forecasting systems, Internet of Things, IoT, databases data, archive files data, transaction details of the customers, right? TV, video games, smartphones data. Data can be anything from anywhere. That is what is called big data, right? So big data cannot be stored in the data warehousing because data warehouse can implement only structured data, right? So in year 2000 onwards, big data era is started, right? So if you wanted to store this kind of a data, big data, concept is going to be offering how to store the data. And the second issue is that how to process your data. So two things always we need to understand. One is called, so big data problems. If you know what are the big data issues, so big data, when it is there, you have to know how to store the data. The second one is called how to process the data. Clear? These are the big issues or big data challenges people are going to be calling these as, right? So it can be any kind of a data. How are you going to be storing? So that is what we need to understand. If you wanted to store the data, especially in Hadoop, right? Big data software is called, we have Hadoop is implemented. And in Hadoop, how are you going to store the data? We discussed Hadoop is going to be giving you HDFS concept. What is HDFS? Hadoop distributed file system to store the data. Clear? It is going to be storing your data into the disk, but the problem is slow, right? That means if you wanted to store the data. One is called, you can have a HDFS. So that is what you need to understand. It is going to be NDFS, means distributed file system. So today in the cloud, how do you store the data? You can go in for data lake. Clear? So Hadoop, we can store the data. If you store this, you can start this big data tools I'm talking about, right? So big data tools. So we have Hadoop. Hadoop can store the data here, and the Spark. Do you think that Spark can store the data? Spark is getting the data from somewhere. Spark is completely data processing engine, right? It can store the data into the RAM, but Spark is going to be data processing in here. Processing can be done. So with the help of map reduce, MR, people will be calling this as MR. Whenever you see this map reduce, which is a completely Java based program, so it is more complex. That is what we have discussed. Hadoop is released in year 2006. And so if you wanted to store the data, either you can go in for HDFS or a data lake, or you can store the data in your any file system. For example, if you store the data in my Windows, I can go to C drive or I can go to D drive. How do you store the data? Create a new folder. Now I will be able to say this is my sales data. So I will be able to get one Excel file, maybe PDF file, or maybe anything. It will be sales data I have. Let me double click on this and so store my sales data. What is that? Order ID, right? Product ID. So customer ID, like that. I wanted to store product number, customer number, right? This is the product, and what is the sales amount, right? I wanted a sales amount is 1200. Now I will be able to sale date. So I wanted to store it is December 12th, 2021. So when you have this data like this, your data is going to be stored in your local file system. So Windows is going to be giving you the data can be stored in NTFS file system, new network file system. If it is a Linux or Ubuntu operating system, it will be EXT file systems, right? These are completely not a distributed file system. So this is a distributed file system. Clear? So we have file systems are two varieties. File systems are two varieties, types. Okay. File system types I'm going to be talking about. One is called distributed file system. One is non-distributed file system. One is called distributed file system, right? So what is a distributed? It is going to be distributing the data. How it is going to be distributing the data? We'll talk about it. It is distributed file system. One is this. So the second one is called non-distributed file systems. The example, we can have HDFS, or we can go in for even data lake. Many times we've spoken about data lake in Azure, right? So this is distributed file system. Now, non-distributed file systems are your Windows file system, your Linux file system is called EXT file system is called Linux, or your Ubuntu file systems. Clear? So what is a distributed? You're going to be learning now. So remember that. So how to store data? You may store data anywhere, but we are not worried about this one, especially either we store the data in HDFS if you install your Hadoop, or if you're using Azure, you may be using a data lake. But if you're using Amazon Web Services, there is S3 buckets. S3 is also data lake only. Azure is going to be giving you data lake as it is. But when you work with the AWS, people will say S3 buckets. S3 is also a storage area, distributed storage area, similar to data lake, or it is data lake only. Data lake is a cloud storage. So data lake is what we know, blob and data lake, right? So now blob and data lake, both of them are same. Okay, there is no other difference at all. Both of them are distributed, not non-distributed file systems. Remember. But how can we process the data today? To process the data, Hadoop you can use MapReduce, right? This is one way you will be able to use it. But today we are not going to be using this. So Spark is going to store your data where it is going to store your data into the RAM. So because of that, as I told you, it is a faster. So if some data is going to be stored in the RAM means, do you think that permanently we can store the data? So Spark cannot store your data. So HDFS can store your data because it is a disk. RAM, if you shut down the computer, what will happen? The RAM will, data will disappear. So you can clearly say Spark cannot store your data, right? But Hadoop, yes. But Spark is mainly for the processing. Clear? So processing purpose, we invented a language called Scala, and this is where the processing is going to be happening. So how do you do? You are going to be using a Spark completely for the processing. Either you can use Scala, and everybody asked, so can we use Python? Then even Python is also implemented. Can we use SQL? Yes, that is also implemented. Or can I use Java? That can also be implemented. But problem with the Java, it is a complex. Clear? So Spark is completely data processing engine. Data processing engine. It cannot store your data. Be clear. But Hadoop can store your data, and it can process the data with the help of a map reduce Java complex. Now instead of a map reduce, this is implemented. Remember, so instead of a map reduce, this is implemented. Now you can write any language, either Scala or a Python, SQL, Java, but many people are going to be using Python. A new language called PySpark is implemented. New language called PySpark, or most of the code, many people are writing Spark SQL, right? You can also write the R language. Lot of languages are supported here. Lot of languages are supported, but Databricks or the Spark is going to be where you're going to be writing the code, either PySpark, Python coding with the Spark library. Clear? So data processing engine Spark where you cannot store your data. If you wanted to store your data, either you can go for HDFS if you installed Hadoop in your premises, or you can keep all the data into the data lake of Azure. If it is AWS, you can use S3 bucket. S3 also data lake. Data lake is what kind of a data storage? It is a distributed file system. Clear? Data lake is a distributed file system. You can, if you want to process data, you can go in for MapReduce. MapReduce is gone. Spark is created in 2009. Clear? So that is what already we have discussed. Data processing engine, it cannot store your data. So storages are, you need to be clear, either Hadoop distributed file system or data lake. So we are going to be using data lake only, because Hadoop we don't touch at all. But you need to know what is a distributed file system all about. Clear? The next one I have spoken about, cluster we are going to be using. Why cluster? Because you cannot store the data horizontally or vertically. That is what we have discussed, right? So big data properties are commodity hardware in a cluster, distributed, parallel, fault tolerance, 100 times faster, stores data in the RAM. Apache Spark is a big data software to process a large amount of data. Apache Spark cannot store your data. If you want to store your data, you can install Hadoop in the cluster and try to store in HDFS. Otherwise, forget about HDFS. We have a data lake, that is again distributed file system only. Clear? Now, so this is what we have discussed yesterday. Now, vertical and horizontal, storing architecture. So you can take one single computer, keep on adding what is called hardware. So one day you will not be able to increase the hardware because motherboard and nothing will support. It will fail. But if you keep on getting more and more data, what you do? You're going to be adding the nodes. These are called computers or the nodes. Simply, all of them are a computer. Machine number one, machine number two, machine number three. If you're getting so much of a data, what you do? You add some more computers. This is what is called a cluster. So, single node architecture versus multi-node architecture. These nodes are computers. You can have commodity software, hardware, cheaper hardware. You can also, if you're increasing the data size, 100 GB of data today, tomorrow you may have 2000 terabytes of data also fine, because simply buy one more computer and attach it. Buy one more computer and attach it. So all the machines need to be having a software, either Hadoop or a Spark. Clear? Spark software you need to install. If you wanted to install, are we going to install manually? Answer is no. But if you wanted to install Apache Spark, what is that? You need to have, every machine need to have Linux operating system. Okay? Linux operating system is recommended for either Spark or Hadoop. So Linux means what is the version? Ubuntu, right? Then Spark is and Hadoop is prepared using a Java virtual machine. So JVM you need to install. Once it is done, after that, what you need to install? You need to install either Hadoop and the Spark in each and every computer. Here you need to install, here you have to install, everywhere you have to install them. Clear? If you have 4,000 machines, in 4,000 installations you need to do in, Linux, Ubuntu or Red Hat, lot many flavors are available in Linux operating system. That is what already I've discussed. I'm just repeating. JVM means Java virtual machine you need to install. Why Java? Because Hadoop and Spark is prepared using a Java language. Java you need to install. Then what you need to install? Hadoop and Spark. So companies are not using only Spark today. Remember that point. No company is using only Spark today. All companies or majority of the companies are using Hadoop as well as the Spark. Hadoop to store your data, HDFS, MapReduce is going to be failing. Instead of a MapReduce, we're going to be using Spark engine to process your data. So only pure Spark, you don't get it in any real time. So people are going to be installing Hadoop on top of that Spark. Both of them can be sitting in your single computer, right? But anyhow, we are not going to be, working with the Hadoop, but Hadoop architecture you need to know clearly, and that we'll discuss in couple of, sessions later. And the Spark, if you want to install, so this is what you need to have it clear. So vertically you cannot grow, and horizontally you can, grow. So this is very, very important. So data storages. So these many things we have discussed. If somebody asks you data warehousing or big data warehousing data is a centralized data, single machine, decentralized data, costly hardware and big hardware you need to buy it. Commodity hardware means cheaper hardware, you can buy it and keep it. And a single machine, it can store the data processing, multiple machine store and process, and distributed architecture answer is no, it is a distributed data. No parallel data processing can happen. Parallel data can be processed. Risk, heavy risk, because one server is down means entire your OLAP system. Data warehousing is also called as OLAP because you're going to be creating a lot of reports using this. So a lot of Power BI reports are going to be, prepared using this. It will be called as online analytical processing. Lot of reports are going to be generating here. So here, no risk and only structured data, structured, unstructured, semi-structured data. Database, you will have a tables, but in the big data, most of the time, we are going to be storing what kind of data? Either data in unstructured way, semi-structured way, or structured means delimited files. So you can say, I have employee ID, comma, I have employee name, comma. It is a delimiter. So structured data will be stored exactly not in the tables directly. Structured data will be stored using a delimited file formats. Clear? So that is what you got to understand. So one computer here, cluster here, batch data and historical data, you can have it. So here, batch data plus streaming data. Data warehouse cannot deal with the, streaming data. Streaming data means live data. The data continuously arriving. The data continuously arriving, that is the data big data can process. Especially your Spark engine can process live data, streaming data. Hadoop is also good for processing batch data, right? So data processing can be done in two ways. One is called batch data processing and live data streaming data processing. Spark is good for this. Spark will be good for this, but Hadoop cannot do the streaming data. Hadoop is good for batch data. Batch data means what? Historical data, old data, right? Read only data called as a batch data. Last 20 years of data will be called as a batch data. Clear? Last 20 years of data is called as a batch data. Historical data. Streaming data means continuously you are getting the data. That kind of a data, your data warehousing cannot process. Even Hadoop also cannot process the data. Clear? So these are the difference between data warehousing and big data means a cluster only. Data warehouse means a single machine only. Clear? So this is what I have discussed, and especially all the data in your Medallion architecture we were discussing about in ADF. All the data initially you're putting into a landing zone, or you create a folder in the data lake. All the data you're going to be dumping into first landing zone. You create one data lake. The data lake, you create a folder called landing folder, dump all the data with the help of a ADF, right? Already you have used copy data activity, dumped on all the data into the a folder called landing folder. Okay. From there, we are going to be, creating this data, and, we are going to be taking the data from the landing page to then dump into branch. Then data engineering team is going to be coming here, especially ADB developers. Databricks developers are going to be picking all the data from the landing. Then they'll see what kind of a data, what kind of a the cleaning work we supposed to have it. Everything will be done from the bronze to silver to gold, right? Silver layer, where you have lot many cleaning work will be done. The silver layer data can be taken by your data, data cleansing work will be done. Your AI people can take the data from the silver layer, right? Because cleaned data, you kept it ready. So from there, the AI people can be taken. Data scientists, machine learning people, data analyst also can take the cleaned raw data from the silver layer. But some people will go further, and the raw data, the cleaned data from the silver layer can be aggregated and kept ready. And you're going to be having dimension tables and fact tables as part of your gold layer. Now here, the storage will be delta tables. What is a delta lake or a data lake? That I'm going to be discussing now, because this is a good concept and a new concept in the Apache Spark. Especially Databricks is implementing one more new concept called uh, delta tables or data lakehouse tables. So this is very, very important feature that you need to understand. Clear? So you need to assume that we are going to be completely working on the big data. Right? Big data means completely from one layer to another layer, the data is going to go. Now, from here, whatever be the data you're able to get it, this data we are going to be dumping into Parquet files, right? Parquet files are faster. So these are columnar storage files, right? Data can be stored in two ways. One is called data can be stored in the row format. So this is a row. So data storage is two types today. One is one is called row format data, Excel, RDBM as text files or any data. Normally, you're going to be storing data storage is a row. So this will be always slow. Clear? Always slow. But it will be used by the human beings to read. For example, my employee ID is one comma, my name is Ram, comma. my salary is 10,000 rupees. No, when you read the data, you will get full information, right? This is row storing. But the problem with the row storing is, if I wanted to know the second employee called Sita, now her salary is 20,000 rupees. Now, this is one more employee data. So, row database always focusing on a single employee information, but we cannot store the data like this. I wanted to take this raw data. Now, tomorrow, what are we going to do? We are going to be taking the data and analyzing column wise. So I'll take complete salary. I will ask what is the total salary, what is the average salary. So we are going to be working on not row wise, we are going to be working on a column wise. Clear? So the next thing you need to understand how we are going to store your data column wise. So this is one more data storing technique. One more data storing technique, that is a columnar database. So data you supply through rows in Excel sheet, but in the Parquet files or in the columnar databases, the data is not going to be stored in the row wise. It is going to be splitting into column wise. So architecture is going to be completely changing. So this is what you need to know, right? So for example, I wanted to talk about this data. So what is that? Let me say one employee ID, employee name. So employee salary, let us take employee number one, Ram, salary is 1,000. Employee number two, Sita, salary is 2,000. So city I wanted to have, she is from Chennai, she is from Bangalore, right? He is from Chennai. Like that, I have some data. So I have thousands of data that I'm going to be having it here. Let us say John, 1200 and from Bangalore, right? And let us say you have Ahmad from, let us say, uh, 3000, right? Is from, let us say, Chennai. Like that, I have some data. No, this is the raw data format. This is how your Excel sheet is going to be storing. It will be good human beings to read, but machines will not work on the raw data. They don't need, especially OLAP machines. So what will happen? Instead of storing the data in this, it is going to be creating a column. So when you supply this data will be taken separately. Control C, it is going to be storing a column wise. So this is a columnar database. Okay. So this is how you can store in the columnar storage. Column storage. People will say that is a row storage, that row storage or Excel sheets, your RDBMS tables and everything, right? So column storage will be good. So these are example for your Parquet files. Okay. Parquet files is a columnar, or even your Power BI going to be storing the data into the columnar storage only. Because of that, Power BI is also faster. Now it is going to be taking this data and try to store the data in this architecture. It is going to be storing in separate column here, right? And it is going to be taking and storing this data in separate column. So like that, you need to understand data row structure we are going to be maintaining, but when reads the data, Parquet files are going to be storing. The advantage here, whenever there is a duplicate, duplicates are going to be removed from this. We have Chennai, Bangalore, Hyderabad repeated. It is going to be taking only one unique data. Remaining data, it will not store. It will create one more table inside that. It's going to be creating, some primary key values and try to, maintain the data separate. So instead of storing Chennai, Bangalore repeatedly, it is going to be deleting, and the data compression is going to be happening here, right? So whenever you ask, what is my total salary? So how the processing has to happen in the row database? It has to visit, is it salary? No. Is it salary? No. Is it salary? Yes. So you take the data and keep it separately. Then it will go, is it salary? No. Is it salary? No. Is it salary? Yes. The salary it has to bring like this. Then it will go to this row. Is it salary? No. So like that, to get the salary, it is going to be reading from first value to till it gets. So it is going to be wasting a lot of time, and all the salary values it has to pick up, then perform the total. So in the row database, what will happen? Unnecessary readings are going to be happening. You're slow to read and process your data. That is the biggest issue with your row databases like Excel sheets, your column delimited CSV files, maybe your RDBMS databases are very slow. But when you go here, already data kept like this. I need not search for the data. I need not do anything. Simply I go to this column. I will be able to read quickly and get the total. So it is very fast for the processing. Okay, faster for the processing. It is going to be work on the large amount of data always. It is going to be working on the large amount of data. If you convert this data into columnar data, columnar data is always good if you wanted to read the data, but row databases are always good when you wanted to read a single row. For example, I wanted to know what is my balance. Now you go to the ICICI Bank or State Bank of India, you have to give your number. My number is 1. I wanted to know my account balance. You have to always read a single row. So if you wanted to read a single row, row databases are good, right? If you wanted to take large amount of data, do on that summing process, find out what is the total, what is the average. So these kind of activities are going to be happening, especially in the data warehousing systems or in the OLAP systems or in the big data systems, right? So both of them are good, but where you need to read row means it is OLTP databases, transactional databases, where we are going to be querying what is my balance. Always you're going to be focusing on one row or a single row or a few rows. So what is the next question you ask? What is the last 10 transactions I have implemented? 10 rows, if you read, that is enough. Last 10 transactions you wanted to see, or last 1 month transactions I wanted to see in my bank. Maximum 10, 20, or 30, or a maximum 100 transactions you read. So if you wanted to read one row or a few rows, OLTP databases are good, because OLTP databases like SQL tables or Excel or CSV files are going to store the data in the row format. Clear? But whereas when it come down to data warehousing systems, or especially data warehousing is also going to store your data into the columnar format only, especially big data environments, right? Where the special architecture is designed to store your data, that is columnar data. The columnar data, the best example is called Parquet files. Clear? Parquet files or Parquet files. Parquet. T silent sometimes or Parquet. Anything is fine. You will be able to store the data there. So that data, when you have a large amount of data, if I wanted to get what is the total sales in Hyderabad, or of the what are the total sales in, let us say Bangalore, you will have millions of data for belong to Hyderabad or belong to belong to India or South India, or you need to go to this column directly and try to read the data and perform the summing operation. So these are the two things that you need to understand. Clear? So that is what is very important. Always row databases data we are going to be converting into Parquet files. From the Parquet files, the data will get compressed and we're going to be cleaning, and the cleaned data we're going to be dumping into Delta tables and everything. Am I clear? So that is what you need to understand. Okay, what is a cluster? A Spark cluster is the backbone for the distributed data processing in Apache Spark, allows Spark to scale across multiple machines and handle massive data sets efficiently. This is what is called a cluster. And along with that, Spark we are going to be using. Clear? Now, what is a Databricks? Databricks is a company formed by creators of Apache Spark only. Databricks provides an Apache Spark based unified analytics platform optimized for cloud. Working with the open source version of Spark involves addressing several key challenges as given below. Infrastructure management. If you wanted to run your own cluster, you need to buy hardware and configure them. and software installations that you need to do it alone if you're running your own cluster, or upgrade, lack of user interfaces, managing the security, all of them, if you're running alone, you need to face it. But Databricks, when you take it, everything it is going to be handling for you. Clear? So these are the working with the open source version of the Spark. If you have, for example, you decided I wanted to implement Spark in my company. So you need to, the first point is what? Infrastructure management. You need to buy a lot of hardware. If you buy hardware, that is not sufficient. Configurations, the routers, the networks, and some people have to maintain and 24 by power supply, a lot of things. And software installation, you need to do it. So instead of you doing everything, you better go to Databricks. Databricks will be installing Apache Spark only, but it is going to be giving you all these benefits. Infrastructure management, these fellows will do, and the software installation, these fellows will do. Upgrade any time Apache Spark is going to be giving you new patches. So these people will be upgrading. Lack of user interface. If you have Java, then Java user interface you need to have. If you wanted to write SQL code, SQL user interface you need to have. If you wanted to write a Python code, Python user interface you need to have. So many user interfaces, people have to learn. So this is also not necessary, right? Managing the security and lot of other things. Who's going to be doing? Databricks is doing. Instead of you buying a hardware, you maintaining your independent Spark applications, it is completely useless. And instead of that, you better go in for the Databricks. All of them, Databricks company is going to be doing it for you. It will be paid software. Apache Spark is a free, but Databricks is a paid software. It is going to be giving you all these features, right? So to store big data, we have discussed. So Apache Hadoop is gone because of two reasons. It is slow and complex. And Apache Spark is not going to store your data, and it is going to be processing the data. It will store the data into the RAM, but it is not permanent storage, right? So by default, Scala language, you get it. But today, we don't use Scala. We don't use what? We use Python. Python with the Spark, PySpark. Clear? And Databricks is a paid software. You will get lot many features as discussed earlier. Are you clear? Now, data storage, as we know, storing a data, either you can use your databases or you can use through files. Files means again standalone means this one, NTFS, EXT, or a distributed means HDFS or S3, even data lake also HDFS architecture. You may use Oracle, MySQL. These are the normal databases. We have NoSQL databases also, HBase, Cassandra, MongoDB. What is NoSQL? It is not only SQL, not only SQL. Okay. SQL, where you can create a table and store your data. The best example is employee ID, employee name, employee salary, or sales ID, sales, product ID, or order date, or you can have order amount. So this kind of a data we can store. But I wanted to store a documents, docs. For example, you will send me your CV, I will send me my CV. Now your CV is a document. My CV will be having one more document. Think about your naukriportal.com. Naukri portal cannot store all your CVs in the C drive or D drive, right? So tomorrow, so what you ask, you go to naukri.com, you say people who are having more than 3 years of experience, and people who know SQL, people who know Databricks, people who know, let us say, SSIS, I wanted to have, and people from Hyderabad. So this is the requirement for the HR. So HR will go to naukri.com. HR will type this. I would like to have 3 to 4 years of guys, people who know SQL, SSIS, MSBA, Power BI, Databricks, and people who are currently in Hyderabad. If you give thousands of CVs, if you give thousands of CVs, and it has to open the CV and look for the address, and it has to look for the all these details and give the CVs. Now, normal SQL cannot do that because the SQL has to be working only on the table data. But now Naukri.com is not going to get table data. CVs will be uploaded. CVs are going to be uploaded. So normal SQL cannot work. right? So you need to not only SQL, that means not only SQL means, but also other things. So NoSQL means not only SQL. So Cassandra, MongoDB, this kind of a databases where you can upload your CVs, documents, clear history documents, your CVs, lot of them you can upload and write SQL queries and fetch the data. So this kind of a database is also more popular. Clear? So you will be able to use not only SQL, that is NoSQL, it is going to be maintaining data of a documents. So SQL is going to be maintaining the data in a tables. Clear? So you're going to be writing, storing everything in the tables. You're going to be maintaining in the documents. All the CVs on Naukri.com will be storing either in HBase of Microsoft, Cassandra, MongoDB. Lot many NoSQL databases are available so that it is a documented databases. These are called documented databases, not only SQL, NoSQL. Clear? So that is what you got to understand. So if you wanted to store any file, we can go to Microsoft NTFS, new network file system. EXT means Linux. So HDFS, S3, even your data lake in Azure or distributed file systems. So data can be available in these two places, worldwide data. Clear? Now, what is the meaning of a cluster and what is the uh, distributed architecture? Let us understand now. Okay. Now, I wanted to store some data. For example, I have some file here. Let us say I have a 400 MB of data file I have. That is simple file. I'm going to be having it. If you store this data in your NTFS, non-distributed file system, what will happen? Distributed file system, what will happen? Let us understand. So I'm going to be creating a cluster. Okay. Cluster means what will have? You will have one computer, one main computer you need to have. And after that, I'm going to be having a slaves or data nodes. You need to understand the naming convention also. Clear? So let us talk about this is one machine. This machine is going to be connecting with this. Now, cluster always is going to be maintaining like this. So you cannot have a cluster like this, one machine, one more machine. So you cannot say this is a cluster. These machines are cannot talk to each other. This machine cannot talk to each other. So this is not a cluster. So remember that. Cluster always will have a one main machine. These are the slave machines. Cluster cannot, these machines cannot talk to each other. Remember that. Okay. So you cannot have a cluster will be like this. It is completely wrong diagram. Clear? So remember that and try to understand. So cluster, this is what is my cluster. You assume that you have installed Hadoop. Okay. If you don't have installed anything, there is a silk cluster. If you wanted to upload this data, let me go and try to upload this data to the cluster. You don't have anything in the standalone means this 4 MB of data will be going to either any machine, machine number 1, machine number 2, machine number 3, machine number 4, all 400 Mbps data will get saved in one machine. It can be to any machine. How many computers you have? You have 1, 2, 3, 4, 5. This is a 5 node cluster. Node means a computer. Clear? It is a 5 node cluster. So 5 machines are available, but here it is it is standalone. Standalone means it does not have any Hadoop is installed. Nothing is installed. So if you store your data, all the data will be stored either in this machine or in this machine. 400 Mbps data MB of data is going to be stored, and it is going to be 100 Mbps. Okay. So it is going to be taking, say, let us 1 second. So how much of second it is have, or if it is taking, let us say 1 MB per second, it is processing, or 100 Mbps it is processing. It will take 4 seconds, or it is taking 1 minute. 100 Mbps of data, if you have it, it is going to be taking 1 minute to process. If you're having 1 minute, so what will happen? 400 Mbps of data, it may be taking 4 minutes, because all the data is in a single machine, it is going to be taking, 4 minutes of time to process the data. Clear? All the data will go here. It is getting stored in one machine. Only this machine is going to be processing. This is what is called a normal, single, a standalone, or it is not a distributed file system. It is non-distributed file system. But whereas I'm talking about, let me go. And I was talking about one more architecture. Now you have created a cluster and you have installed what? Hadoop here. So let me just go give you a Hadoop cluster. Hadoop. So Hadoop is what it is going to be using. It is going to be storing the data we knew in a distributed file system. It is going to HDFS. It means Hadoop distributed file system. 400 Mbps data will be divided, okay, divided into blocks. Remember, it is going to be divided into the block. This is a block number one. Okay, it is a block number one, block number two, block number three, block number four. All the blocks are going to be blocks are going to be distributed here. Block number one is going to come here. Block number two is going to come here. Block number three is going to come here. Block number four is going to be coming here. So this is what is called block number one. Clear? So block number one data will come. Block number two data will come. Now you can see block number three data comes here and block number four data comes here. So distributed means all the data, it will be 100 Mbps data approximately, right? So when you go, what is the size you can discuss here? 100 Mbps, 100 MB, not PS. 100 MB of data will be first block, 100 MB of second block, and 100 MB will be going to the third block, and 100 MB of data will be going into the fourth block. Okay, so it is what is called as a master machine. So in the Hadoop architecture, one machine will be called as a master node or master machine, where it is not going to store any data. So this is a master node. These are called slave nodes or slave computers. It is master and slave architecture. It is master and slave architecture, or slave nodes, or people will say this is what is called a data nodes. Okay. Slaves are called as data slaves. Okay. So it is a master and slave architecture. It is a computer number one, computer number two, computer number three, computer number four. This is also one more computer. So in the master machine and the slave machines or data machines, everywhere you need to install Hadoop completely. You need to install operating system, that is Ubuntu Linux, then install JVM Java, then you have to install what? This one, what is called as a Hadoop. Clear? So either slave machine or a master machine, everywhere you need to install everything, but you have to configure separately. Core.site XML, there's a configuration file. In that, you need to give which is the main computer, right? You need to give some configuration settings at the time of installing HDFS. So based on the configuration, you are going to be deciding which is my master machine, which is my slave machines. Clear? So I need not give you that complete information, but there is a core dot, okay, site.core. I don't remember this. This is one XML file is going to be there. In that, you need to add one IP address. So which IP, which computer among this can work as a master? You need to give that IP address so that either this machine, any machine can become a master machine. So master machine, what you have? You don't have any data here. You don't have any code here, but what it is going to be doing? It is going to be maintaining metadata. So master node is going to be maintaining what? Metadata. So metadata. Metadata means it is data about data. It is going to be telling. So in the slave number one, I have stored block number one data. In the slave number two, slave machine number two, it is slave machine number two. In the slave second machine, I'm going to be storing block number two data. Clear? Like that, it is going to be storing metadata information. Clear? So it is a slave number one. It will be a slave number two or node number two. It is data or a data node or slave node. Anything is fine. So actual data is going to be stored in your cluster in the slave nodes or the data nodes whenever you load. So this is a cluster, whenever you upload, this cluster is actually connected to one more computer. Cluster is connected to one more computer. This computer is called as edge computer. This computer is called as edge computer. So this is your machine. Okay, this is your machine. From your machine, you have this data. So what you do from this machine, you are going to be uploading this data to the edge computer. Edge computer will be uploading the data to this. Okay. You don't come directly to the cluster. You don't upload the data. Always your machine is compared to the edge node, right? This is also one more computer. This is a starting point. Whenever you upload any file here, from here only we are going to be getting the data. So all the data will get distributed to your this one. So edge may be connecting to this node or edge may be connected to a cluster. But remember, you don't directly go and put the data to the cluster directly. You have to use edge computer. So what is edge computer means? Which is connecting to the cluster. So as a customer, you're going to be talking to the edge computer. From the edge computer, data will go. So if it is HDFS, means all the data will get distributed here, right? So it is going to be storing. So we are talking about a data lake, right? We're talking about data lake also. Right? Data lake is what? Data lake is also a cluster only. Data lake, Azure is going to be maintaining a big cluster, right? So it is going to be, this is the main computer. So this is how we are going to be assuming it may be having 4,000 or 40,000 machines are working together. So whenever you go from your computer, this is my laptop. So what I do, I go to portal.azure.com. From my machine, I'm going to be storing my data to the data lake. I'll upload a file. When I upload a file, for example, I'm having, let us say, 400 MB file. 400 MB data I'm going to be uploading. So this data I'm going to be uploading into data lake. So for me, it is a folder. For me, it is a folder. One folder I will upload, but it is going to be distributing 100 Mbps, 100 MB data here, 100 MB data here, 100 MB data here. So this is what is called a data lake architecture also. Data lake is a cloud storage. Data lake is maintaining a cluster. Azure is going to be maintaining a cluster with many machines. Clear? If you go to data lake and create a container there, create a folder there, you need to assume that your data is going to be divided into blocks. Okay. So what is the block size here? Block size will be 100 Mbps and 100 MB. So that is what I'm telling you. But in HDFS, the block size will be 128 MB. Okay. In HDFS, what is HDFS is not going to store the data as it is. It is going to be creating a block. Okay. What is the default says? It will be 128 MB. So it will take 400 MB divided by 128 MB. You will get three blocks and some, the fourth block may not have full data. So it will, go lesser data, right? This can be configurable. You can make it to 256 MB. You can make it to 64 MB. Depends upon the cluster size. By default, it is 128 MB. Here also, data lake also, when you have a 400 file or if you take 1 GB of file, 1 GB means 1024 MB divided by, if you have 128 MB. So you can know how many blocks you're able to get it. 1024 divided by 128. How many blocks? It is, I think, 8 blocks, right? So what is that? You can do the calculation. 8 or 16 blocks you will be able to get it. Each block data can be stored in different computers. So the master machine, master node is not going to store your data. Master node is going to be storing what? Metadata. Clear? So which is a master computer, which is a slave computer, which is a data computer, that you have to know clearly. So HDFS is going to be storing the data in the block wise. Clear? Blocks it is going to be maintaining. Even your data lake is going to be storing the data in the blocks. Clear? So that is important, guys. And I think time is over. We'll continue tomorrow, and I'll show you how to work with the opening subscriptions and everything. So this is what is called your architecture about a cluster. Okay. So without a distributed architecture, how it is going to be working? With the distributed architecture, we're going to be dividing the file into blocks. What is the block size? Already it is configurable parameter inside your HDFS or inside your data lake. So by default, which is 128 MB. Clear? So that is what you need to understand. So if you have any questions, you will be able to ask me. So batch processing and streaming data. So that is what data storing we have discussed. Data processing means batch data. In the batch data, what normally we do, we get the data. So get the data, get data. First, we store the data in the file or tables. Then we are going to be processing the data. This is what is called batch data, normally historical data. So batch data means this is what you need to understand. Batch data means historical data. Remember this point. Your data warehousing systems, OLAP systems are going to be using this. The next kind of a data processing I'm going to be talking about streaming data. Okay. So batch data processing, streaming, this is get the data. Now the next one, streaming data. And the stream data are called as a live data. So what is that? In that, we get the data first, but we don't store. Get the data from the computer. So when you swipe credit card, what will happen? Your data will be processed first. Why? Whether it is a fraud transaction or not, it will verify. Computer will verify. Then it stores the data. Clear? So batch data means historical data. For example, you swipe, you go to ICICI Bank or do any transaction. So the data will be saved in the OLTP system. Then data will go to data warehousing system. It will get saved first. Then once in a 6 months, once in a 3 months, we'll see what are the total number of transactions have happened. So when you work on the historical data or old data, large amount of historical data means a batch processing, right? But second one, whenever you wanted to, swipe a credit card, that should not be stored. You need to first process whether it is a good or bad transaction, fraud or not fraud. So that is processing. If that is cleaned, then the data will be stored. So this is a live data, stream data. So both of them can be worked in the Spark, but Hadoop is going to be only good for this. Hadoop only good for this. Now Spark can do this data processing, and this is also Spark can do, right? So Hadoop cannot do that. Remember that. Okay. Spark can do batch data processing, stream data processing. Hadoop only can do batch data processing, not the stream data. So this is also you have to know clearly, right? So Hadoop, batch data processing, Spark, batch and stream. Only if you need stream data, there is Apache Storm is available. This is one more software, right? It can also only process Apache stream processing data, but Spark can do batch and streaming data also. In Apache Spark architecture, so you need to learn Spark SQL, streaming, M library, and GraphX. These are not needed, but Spark is going to be giving you M library for the AI people to work on, and a dots and everything. It will be for your Facebook, LinkedIn people are going to be using. We are not going to be using GraphX data, Spark SQL, or we are going to be using on the PySpark data and streaming. Remaining things we don't work. So Apache Spark architecture is supporting everything. So it is for the batch processing. It is for the stream, either Spark SQL or you write the code in PySpark, or maybe Scala. Okay. So that is what is very, very important, guys. Okay. So all these things we have discussed, and in a Spark, SQL, data frames, streaming data we work on, M library for the machine learning people, graphics for the graph computation. So Spark core is going to be having R language, SQL, Python, Scala, Java. If you learn Python and SQL, and if you know this one and this one, it is sufficient. These are, even though Spark is supporting, but we are not going to be working with the machine learning things and GraphX modules also. We don't work. We're going to be working with Spark, SQL, and data frames. What is the data frame and all we'll discuss, and the streaming data we will work. You can learn SQL and this one. Remaining things we don't want to learn at all. This is Apache Spark. What all you have done means you need to say Spark, SQL, data frames, and streaming data with the SQL and the Python code I can write. So remaining things you need not worry about. If you know Spark means these are the two things you need to say in the interview. Clear? Chalo, guys. So Apache Spark deployment modes, we'll talk about standalone, multi-node, yarn, Mesos. We'll continue tomorrow. If you have any questions, you can tell me, guys. Okay. So now I would like to show you how to create a subscription, right? So we have two options. One is called, we can go to Azure portal. We can create a free trial. Does not give permission to create a cluster. It will be very, very costly. Free trial means you cannot create a cluster. Paid service means the cluster will take lots of money from you. So we don't use Azure portal at all. So what we use, Databricks company is going to be giving you community edition. So lifetime access for the Databricks. So we have limited permission, that is okay, sufficient for the learning purpose. So where are we going to go and create our, this one? You can go to Azure. So what is Azure? You can go portal.azure.com and you can create your free subscription. Click on this. You can go try to implement this. Portal.azure.com. You can go, mine is a paid one. So you can say Databricks. You can go, Databricks is one more software here, one more Azure Databricks. So simply click on this. Now you will be able to create, already have created one, but you can go and create one more, right? So you can create or you can delete the existing one. So you can create one more. So you can give the, what is a subscription? It is a paid subscription, resource group. It is for the Star Health new workspace name, folder name. It is Star Health. Okay. And you can say new ADB project. So Databricks DB project. I can give some name like that. And I want to store them in central. And what is the pricing? Role based, blah, blah, blah. Premium or the trial. 14 days trial I'm going to be creating. Now simply review and create. Very simple. You can simply go and create a Databricks project. Workspace means a project. Workspace means a folder or a project. So click on this. Very, very simple. You should be able to go and create a Databricks project in your Azure. Remember, it will be costly. So I can create, but I will delete this. Okay. I don't, use it because it will take a lot of my money. It is done. That's it. Creating a project here is very, very simple, but we don't use. We are going to be going. So community edition. So when you go to community, so community.cloud.databricks.com. So you can go to Google and try to say, let me go to first Google and you can say Databricks Community Edition, Databricks Community Edition, right? So this is the one you need to create. It is a lifetime free. Go click on this. Databricks Community, try free and pay as you go. I don't want to go. So Databricks Community Edition, when you come down, you will be able to get. It is from the Databricks company. Click on this. It will be lifetime free. For the learning purpose, it is sufficient. But actual projects and all will be executed in this only, right? So, but for learning purposes, this one, use a legacy community edition, sign up for the free edition. It is going to be giving me a sign up. So if you don't have anything, you will be able to go sign up. Okay. Free edition, you will be able to get it. So you can give your email ID and try to sign up. So, right. So let me continue. Community edition, you need to sign up first. So use legacy community, continue with email, or you can use a sign up. Okay. So sign up, it will be asking you your email ID. And when you give email ID, for example, I give new email ID, Bhaskar, let us say jogi@gmail.com. When I give, it is going to be creating one account. Okay. It is asking me uh, the OTP it would have sent to my email ID. Databricks verification code, I got it 7 VA PJJ. So Bhaskar Jogi, account name, click on continue. So United States, no. Let us say India. So let me have it United States, click on continue. And I need to start one puzzle. So match this. Where is the 5 you have? Match the number of rocks with the number of the left. How many rocks you have? Is the one. So 1, 2, 3, 4, 5. Yes, submit. Okay. One puzzle, I need to do it. And simply, I can create one free account. So you can also Google it how to create a free account. So otherwise, you can ask me later also. I'm going to be having one community free edition. It's very, very simple. We can create community dot this edition so that you will be ready with this and you can work with that. Okay. So it's going to be, giving everything is ready. Now I can create a workspace. Clear? So everything we'll discuss on the next class. Now everything is ready within fraction of seconds. Now I'm going to be using bhaskarjogi@gmail.com as well. I can work with this, right? So that's how we can open Databricks Community Edition. Workspace means you're going to be creating your own projects and your data, everything will be available. Compute is your cluster. You need to create the cluster and try to make this on. So this is the project name that you need to work on. It's very, very simple. You can try to use this, guys. Chalo. We'll try to continue further. Hope you have enjoyed it. So how to create a community edition, I have explained. So this is a lifetime access. So we'll be talking about all these things in the later classes. Chalo, guys, we'll discuss. So this is assignment, create a community edition, create Azure Databricks edition in Azure, enable DBFS and upload data files. So third and the fourth step we'll discuss next class. This one and this one we'll discuss in the next class. Chalo guys, any questions, you are welcome.